Hey folks, just want to do a quick overview of Chapter 17 as we wrapped up this semester. This chapter is really about the introduction of dummy variables. Typically that's flags of 0 and 1 for a particular independent variable, your x variable. Up to this point everything's been pretty quantitative in your x's. Now we're going 0, 1. So as we do this, we tend to allow ourselves a float, so we'll call it a D in this example, where D, 1 is female and 0 is male. And in this case, if we want to try to see if we can float things together, we'll do that. It allows us to look at models like this, where we see we have our intercept, and now we're trying to determine what our next beta 1 and beta 2, this being a quantitative variable, the D being the 0, 1. When we do the regression, obviously we get back to the normal B's that are a nice representation of what we estimate. In situations where that value of the dummy variable is 0, notice it goes away and becomes just a nice linear regression. But when it's 1, notice what it has is an effect on what the y-intercept, in this case b sub 0, has an additive value of this b sub 2. That actually pushes the y-intercept up or possibly down based on the value. So it does shift the intercept, and you can kind of see that here in this picture. We see that with the value being 1, we see that for D we see it float. If not, it's just a linear regression. If we had an example where we're trying to figure out whether or not we have some impact on salary based on experience, whether or not you're a male, 1, 0 female, or age, if you're over 60 or not, we could run this regression, 1 being is 60 or over, 0 is under 60. Run the regression, we get this. We see our leading coefficients, the impact, everything hold constant, nothing else happening. We see 1 year of experience adds $1,000 onto our salary. Sort of here, it's like a load. It's as if everything all being constant. We had nothing, people would make $40,000. We know that's not true. Here for males, males tend to make about $13,900 more than females. And the case of D2, as we saw, people that are 1 is over 60, 0 is under 60. If you value 1, so you're over 60, you make about $4,000 more. Notice in the p-values, the experience is significant. In this case, gender is significant. And in this case, if we used alpha as 0.05, in this case, D2, again, 60 or over is not significant. Now, we're not breaking it out based on 0 or 1 being significant. We're taking it for the group 0 and 1. We now know that a male professor makes this, and we just talked about how we can see the equation be run out. So, if we think more broadly about what we've just seen, we can now test the significance of this using t-tests as I've kind of described it. We'll set each of the betas that we want to examine, if it's quantitative or qualitative, to 0 and see if we can either not reject the null, meaning, hey, we can set to 0 and it's not a problem, or if you reject the null, you say it has to be something other than 0. And in these cases, we're trying to capture this. And what we have a problem of is when you have multiple types of the 0, 1 or dichotomous situations. Say you have 2 groups and we're trying to look at 3 things. So 3 categories of something. We wouldn't have 3 dummy variables for the case of public transportation, driving alone, or carpooling. What we'd have is 2. You flag it 1, 0, meaning public transportation, 0, 1, driving alone, or 0, 0, carpooling. There is a fourth 1, 1, which you could count for another one as well, and that seems to be kind of a quirky thing here, but you can see how we would flag these. You can't, in this case you'll see the D1, D2, you can't have as many values here. We have 1, 2 of our qualitative dichotomous variables. You can't have as many or more than the number of possible categories. At most you can have 1 minus the total. So we had three groups. We have at most 2 here to flag. As we go through, we saw that the intercept before was a dummy variable. We got to be really careful about this trap, because when you have too many, lots of correlation happens. You really can't do a good job of estimating a model, and what happens is we have models that don't work. This is why we have to say 1 less dummy variable than the total number of categories in that area we're trying to look at. Interaction is another big thing, where we look at the interaction between something like x, which in this case would have been experience, times a dichotomous or dummy variable. So you'd have an additional variable that looks for interactive. Typically think about interaction. When we talk about interaction, we can say that great interactive effect example would be losing weight. People can lose weight by diet or exercise or both. People that diet tend to lose weight. People that exercise tend to lose weight. And people that do both have this interactive effect. That's what we're trying to do here. So we take our quantitative variable, our dichotomous in this case, dummy variable, and we multiply them together as having this interactive effect. If we find that the d value is 1, then we have two x's and they get combined. And you can also see that we will combine and change our intercept. If d is 0, it just becomes linear regression as we saw before, and you can see the impact. D of 0 here means it's just linear. D of 1 means we have the combined x, and we have a shift over here in our overall y-intercept. So when we test for significance, we run the test like we would anything else. So as we've seen before, if we run models, it just looks at experience and the dummy variable of gender. Here we have our regression. We haven't adjusted r squared since it's more than one independent variable. Then I run the experience and the interactive effect, and they have this. Notice I don't have the dummy variable. It either fell out or we're not intending to use it. Or I run all three and it has its adjusted r squared. This one obviously has the highest adjusted r squared. It would be the one we'd say is best fit. From this we know, using model 2, that for every year of experience you get an additional $850 in salary. And for the same model with the interactive effect, for every year of experience, since the D1 meant 1 was male, males get this additional effect. Not only do they get the $850 for having an additional year of experience, they get an additional $778 because they're a guy and they got the extra year of service. So it does have an interesting effect with the interaction. And you can see it here, males versus females. This plays out pretty standard as we look at these interactive effects. The last thing we look at is the choice models. We've set the x's to 0, 1. Now can we set the y to 0, 1? So what I'm going to do is I'm going to say, can I predict y? Can I create a probability for it ranging from 0 to 1 and run the regression? So imagine having a regression that you run where the y's are 0s and 1s and the x's are not. In those cases, you can actually run the regression. The problem that we have is when we pick this thing up and put values back in for x to predict y, you can get values that are less than 0 and greater than 1. So because of the fact that linear runs from negative infinity to positive infinity in theory, we have to have another kind. So it's not like it doesn't always work, but it's not the one of choice because it doesn't allow us to stay within the parameters of 0, 1. And if we look at it this way, if we ran the regression with the y being 0, 1, and we're trying to see whether or not we can, from this case, interested in whether the size of the down payment and income to loan ratio influences whether or not you get the mortgage or not, 1 being yes, 0 being no. Here's what we get. Now we can see that we can calculate using all of this what our values would look like. I have, in this case, a loan of $200,000, income of 60%, and a down payment of 20%, you find out that the probability of getting that loan is 28%. That's between 0 and 1, obviously, so we're trying to create a probability. It's kind of hard. We can look at these things and their impact. We know a 1% increase in your down payment means your chance of getting the loan goes up by 1.88%, and a 1% increase in your income to loan ratio also increases, in this case, 2.58%. Not always the best way to go. The logit and then to logistic model is probably the best way to go. This always makes sure the logit is a kind of nonlinear regression function. It is a form of our logistic regression that we use. In this case, we create probabilities and we raise things to a power. Notice it's just normal old regression here that we've seen before, simple linear, but the probability, we plug in the values that were given for the intercept and for our y, and it creates a probability. And we can see, if we look at the y, since this is the vertical axis between 0 and 1, the green line being the logit function, the blue line being the linear function, the green line stays within 0, 1, the blue line does not. So it's always the one of choice. For what we're doing, we're not calculating and running logistic regression. We can't do that in Excel. It'll be given to you. So you'll be given values for the coefficients and the p-values, and you can run this out. We know that GPA is significant. If I pump in the values here that I have, negative 44836 and 1.5448, we get a probability of 0.54. We can see that we're looking at for 3%. What we're trying to do then it's just great probabilities. And when we look at comparisons, we'll often find that the logit transformation values always stay within 0 and 1, but there's always an opportunity for that linear function, linear probability models, to fall outside that range. So that's it for now. If you have any questions, let me know. One more chapter to go and we'll be done.